Very good morning, my dear students. So now in this video we will study about the module 1 second part, that is linear programming problems. Okay, what do you mean by linear programming problem? So it is shortly called as LPP. So it is nothing but it is a optimization techniques, that is to find the optimal value of an objective function, that is you have to find the maximum or minimum from the given question. Okay, linear means all the mathematical functions are required to be a linear or in a linear manner. Okay, so next, programming nothing but it is not refers to the computer science programming, it is refers to a planning in a linear programming problems. Okay, that is about the LPP. So this problem can be solved by graphical method. So let me understand what you mean by graphical method. Means it is a type of linear programming problems, and we can use to solve the two variable problem of LPP. In the question they will give the x and y value, we have to find out the maximum value from drawing a graph. Okay, so what are the steps involved in graphical method? If this question is very important in examination, they will ask you to find the minimum maximum point with the help of graphical method anta. So before solving the problem, we will understand what are the different steps to solve the graphical method. So first, formulate the given problem, that is we have to understand the given problem and formulate what are the objective given in the questions. Okay, second one is from the graph you can allocate the x variable along x axis and y values along the y axis. Next, plot the constant, you join all the variable points with the help of some scales. Okay, next you plot the graph. Next, the constraint, or that is the formulation or the feasible solution, we have to make the surface area little dark or mark the highlighted. So, and find the points by circle from that surface area, that is feasible surface area, we have to mark the a b c d, then find the points at what along the x axis and y axis. Okay, now finally you find the maximum point, that is the optimization solution. If you solve one problem, you will understand this. Okay, next, formulation problem. This question is very important from the module to second part. So they may ask you direct question, solve the following linear programming problem by graphical method. So I already told linear programming problem. Linear means all the content should be linear. Programming is nothing but it is not a computer science department programming writing program. It is an it is an arrangement or systematic way. Okay, and problem we can solve the problem. So they given what in the question, z of maximum is equal to 3x1 plus 4x2 subject to a constant of x1 plus x2 is less than equal to 450, 2x1 plus x2 is less than equal to 600 within a limit of that is x1 is greater than equal to 0, x2 is greater than equal to 0. So this is a they given the objective, they given the constant, we have to solve this maximum point with the help of graphical method. So I will solve step by step, just to remember the procedure how I am going to explaining. Okay, step number 1, write the given equation in terms of equal and give as name equation number 1 and 2. Write x1 plus x2, take that equal symbol, and 450, give equation number 1. Next, 2x1 plus x2 is equal to 600, write on the constant. If it is writing also, no problem. So first step is write the given equation in terms of equal to and name as equation number 1 and 2. So writing of the constant 1, that is x1 plus x2 is equal to 450, substitute when x1 is equal to 0 and get the value of x2. So here I wrote here same, put when x1 is equal to 0, x2 is equal to 450. Just you put x1 is equal to in place of x1 0, so therefore the x2 is equal to 450. You will get the that x2 is equal to 450. Similarly, that is the coordinator for this point is x is equal to 0 and 450. Next, when x2 is equal to 0, what is the value of x1? Just you put x2 is equal to 0 here, so x1 is also equal to 450. That is the coordinates are 450, that is 0. Similarly, you find the constant points for the second equation also. 2x1 plus x2 is equal to 600. Take that, write that equation and put when x1 is equal to 0, what is the value for x2, and put x2 is equal to 0 and what is the value of x1, you have to calculate. Okay, so when x1 is equal to 0, x2 is equal to 600, and the coordinators are 0 comma 600. Next, when x2 is equal to 0, x1 is equal to 300. That is, see here, x2 is equal to 0. When x1 is equal to 0, x2 is equal to 600. When x2 is equal to 0, and 0 means 2 goes this side, and 2 into the 3, 2 is the 3 means 300. Okay, now x2 you will get x1 is equal to 300. So I wrote here when x2 is equal to 0, x1 is equal to 300. Therefore the coordinates are 300 comma 0. So now this is about the second step. I will repeat. First step is write the given equation as it is and make it equal to and give the equation number 1 and 2. And how many equations are there, that much of amount, that much of variable we will get in the graphical. So here only they are given only two equation. And second step is put x1 is equal to 0, calculate x2 value. Put x2 is equal to 0, calculate the x1 value for both the equations. So for that we solve this. Here we got the equations, coordinates are 0 comma 450 and 450 comma 0. Second equation, from second equation we got the constraint coordinate are 0 comma 600 and 300 comma 0. Okay, so from that we will solve, we will look at all the these points, these coordinate on the graph sheet. So write x and y axis. So here maximum point along x axis is, maximum point is only 600 is there. So you can take along x axis 100, 200, 300, 400, 500, 600, and this side also 600. Along x axis 0, 100, 200, 300, 400, 500, 600, and y axis 100, 200, 300, 400, 500, 600. Okay, first point is 0 comma 450. So look at here, 0 comma 450, x is 0, y is 450. So x is 0, y is 450. Just look at that at point C. Similarly the coordinator point at point second point is 450 comma 0, x1 is equal to 450, y is equal to 0. Again x1 is equal to 450 and y is equal to 0. So this line you have to join the, okay, at 450 and this you have to join. So you will get the equation number 1. So this point is, this line, first line is for belongs to equation number 1. Similarly you mark the coordinate for second equation, that is 0 comma 600 and 300 comma 0. So first is 0 0 and 600 point here, and second is 300 and 0. So you join these two lines, that is okay. Now next, second this is about the third steps. So first step is write the given equation name. Second step is calculate the values, that is coordinate point, by substituting, put x by putting x1 is equal to 0 and x2 is equal to 0, you will get the coordinate. Then third step is same points you draw the graph. Okay, now next fourth step is you see the symbol here in the given question, it is less than equal to, so the graph line should be downwards. Okay, just you check, just you draw the lines from the equation number 1. Okay, now next you draw the also equation number line 2. So here very important, the basic feasible solution is nothing but the common area, it is the area where the two lines of area is merging. Okay, that means two lines are merging at the same place. So if you draw from second equation to here, so this line is cannot joining with this point. Okay, and this line is also cannot joining about this line. Okay, so you eliminate, you erase these two lines. This is a common area, that is called as a basic feasible solution. So you mark underline. Okay, understand this. So from the two equation you draw the line towards this towards left hand side, where the common area are both the lines are joining, take that area only. Okay, now so remaining you erase it. So this area is not merging with this and this area is not coincided with this, so this is separate, this is separate. So take the common area line. Okay, now so common area is 0 a b c. So that point is very important. This is about the fourth step for identifying the location. So this graph is called as an, this surface area is called as a basic, that is feasible region. Okay, now feasible region is o a b c. Next, last step is coordinate, and to z is equal to maximum is equal to 3x1 plus 4x2. We have to find out the maximum point at point 0. 0 is, take the maximum equation is given, maximum of z maximum is equal to 3x1 plus 4x2. At coordinate at 0 is equal to, both the values are 0, so z0 is equal to 0. At point a is value is 300 comma 0, 300 comma 0, coordinates are 300 comma 0. Substitute here x1 and x2 value, you will get 900 value. Okay, next at point b, so here 150 and this side is 300. Okay, substitute 150 comma and 300, you will get 1650. Okay, next point c is, at point C, x is equal to 0, y is equal to 450. Substitute here in this equation, you will get 1800. So from these four values, the maximum value is the given answer. Okay, here maximum value is 0 is very less, 900 is more than this, and this is here among these four values 1800 is the larger value. So that is the your coordinate. So z maximum occurs at zc is equal to, and the value is given by 1800, and coordinates are x1 and x2 is equal to 450. This is your answer. Okay, the answer for this maximum point is the maximum larger value, that point, that coordinate you consider, that's it. Okay, this is about the linear programming problem. Okay now, just to remember the procedure, first they will give maximum equation. So write equation as it is, make it equal to, give the equation number 192, and calculate the coordinates values by substituting x1 is equal to 0, calculate the others, and put x2 is equal to 0, calculate the x1. Okay, and these all coordinates are drawn on a graph sheet, and where the common area, where the common surfaces are common surfaces are joined, that surface area is called as a feasible region. Okay na, then then where that common area, just to mark OABC, that at point OABC, just to take the coordinator and substitute all these values in the given equation, that is z maximum is equal to 3x1 plus 4x2. This equation is given in the question. Okay, so among these points, which one is the maximum, that is your solution. Okay, so z maximum occurs at zc, and the value is given by 1800, and the coordinates are x1 is equal to 0 and x2 is equal to 450. I think I hope you understand this problem. So this problem is very very important from the consideration of module 1 for the part second. Okay, thank you.